Hello and welcome back. Today I have something cool. It is really small. It's the FNIRSI scope, and it should go to 110 megahertz, which is a bit a lot, I think, for $60. But we will see. It is from FNIRSI, and it is the 1C15, and it's the latest model. It's the improved, or they upgraded the software. As you can see, it's white and blue, and the other one was black and blue. And I already saw some reviews about the version that was before. That was the 5012H. That one is black and yellow, and yeah, it didn't get up to 100, and this one even says it can go up to 110. So there are two ways I can do this review, and that is just completely burning it because I expect it will go to 110. Well, I decided not to do that. I'm just gonna see, even if it goes up to 40 with the proper sampling, or 50, I would be happy because it is around $60. So what do you expect? So I'm not gonna burn it. I'm just gonna see what is it what it will do. We're just gonna have an open mind and see where it goes. And I like to open it because then we can see maybe on the chipset it runs on, and then we compare that with another review I see from the EV blog from Dave, and that was from the 5012H. And yeah, it's all from the same company, it's the same size, so probably it's almost the same, but we will see. Let's have a look. So this is how it arrived. It came in this bubble foam, polystyrene stuff, and in there it was shipped like this, not just taped on top, and then they put bubbles, which is nice, and then this was really airtight, watertightly closed, and then it comes like this. This looks really nice. And when we open it, they really wanted to arrive in one piece because, again, also in here, look at this. It is also, well, quality. It comes with these standard but proper probes. Here we have the device. I already charged it. I could contain myself and do that. Yeah, well, we all know these probes, but they are okay. So that is not a problem. And for the lower frequencies, we even have this plug, and it comes with a fake iPhone charger. It's super light and it sounds like plastic. And you just charge it in the top, and you already see the difference with the others if you have seen the others. This one has a calibration output to calibrate your probe. That is a nice extra. So let's have a closer look. Okay, here we have it. Well, it seems that there is still some sort of screen protection because it is not that clear. Let me try to take that off. Yes, here it is. Yes, now it looks a lot better. What we have here, we have the on-off and the charge light, I think. Then we have the, here you charge it, here the calibration. Here, sorry, it was a sneeze. Let's switch it on. Here it goes. That is kind of fast. Let me see, you can see the screen like this, I think. That is good. Let's see, we have an OK button, an auto button. Oh, that's very convenient. I use that also on my second. Menu stop, measure, 1 time, 10 times, AC-DC coupling, 50 and ref, seconds, nanoseconds. So this is probably up seconds, down seconds, millivolts and volts. So this is up because then you increase the, yeah. Okay, makes sense. So it's actually plus min, and that's why they put the seconds here, because you do this with your wave. Okay, makes sense. And you can do a signal trigger, you can save. Okay, let's go to the menu. What can we find? I try to zoom in a bit more. Okay, the menu. Well, we have some sort of joystick right here. It says English, or let's keep it to English. Up and down actually walks you through the menu, and selecting options is panning left to right. So it's a bit. For me, it would be the other way around, but okay. Calibration. Remove probes first. Okay, and press OK. Okay. Well, it's doing already a lot of things. You can see it's calibrating on different frequencies right there. And I just leave it do its thing. Well, it seems to be finished now. We go back to the menu, and we can go to trigger auto, or normal. Normal is probably manual then. On the rise or the fall, we have the display, roll on and off. Okay, the measuring out, that's kind of cool. You can add more information on the bottom. Period, MS means width, duty. Okay, cool. It just now is the peak, and the duty and the frequency. That is good enough. And we have AC or DC coupling, or 1 times or 10 times. That needs to match, of course, the probe you're using, but that's also directly accessible here, so we don't need to do anything with this. So we just push again the menu to go out. Okay, let's see how okay, let's see for the probe, because it has its own test, like you see on the bigger oscilloscopes, that you can compensate your probe. So we're just gonna connect that, and well, if you see, it is kind of searching. So push auto, look, and there it is. And we're gonna just play with the basic function. Well, it looks nice and square. We can do millivolts, which increases the waves, and volts, and that's why that bottom is on the bottom, because you get to higher voltage per. Oh, it's losing, it's triggering at the moment that it is too low. So it needs a certain amplitude to trigger, but it was still visible. And you can see it is really starting from 0, so we must have DC coupling. And yes, we have. So if we do DC coupling, it will probably, AC coupling, I mean, yes, it will go to the bottom. And now it's in the middle. Ah, now it works a little bit better with trickling, and for the seconds, same. It's kind of makes sense to put this left to right and this up and down. It is that is smart. I like it. Well, the wave looks good. Can we, if I push a save, what happens? Bloop, saving done. Okay. How can I get this back if I do select? Well, I look later at the pictures. I found something else which is quite neat, to be honest. And that is, you can also move your cursor, and you can see here in the top in the slider where you are. it should be in the middle. So this little arrow here points to the middle, but also the one in the top. Okay, I like that. And up and down is, if you do that, the triggering gets lost. But this is just the measure point or not. Bit unclear, and also I don't get it why it loses its trigger. If you do this, maybe it's a trigger line. Yeah, it's probably a trigger line. And if you go outside your wave, of course it doesn't trigger anymore. Okay. Same then to the bottom when we get out of the wave. Yeah, okay, so that's your trigger line. Cool. Well, let's put a higher frequency than this 1K. Okay, yeah, there is probably a manual, but I was just clicking around a bit. And there is also here the 50% button, and I think they learned from the other models before, because if you move this up and then move this right and you wanted to push it back, you needed to scroll back yourself, but you can also put here and then you have different options which one you want to put in the back. But if you select them all at the same time, it'll just put it back where it was. And to save, you push this picture is safe. To restore it, you need to do a long push. Then you come in the menu, you click OK, and you can see your stored image view. It says in the corner. Now I'm back. Okay, cool. Put signal. So we are now going to connect the signal generator to the oscilloscope and just see what it does on certain frequencies. I have here the field tech signal generator. What we need to think about is that the impedance also can play a role. So I have here this BNC cable, impedance also 50 ohms. The generator is also 50 ohms. So maybe you heard something about terminating, and that is indeed what we need to do. And why we need to do that? Because this one is not 50 ohms, it's like 1 mega ohm, so it's like nothing. Super high impedance, that's nice. But if we don't want to have any weird reflections in the cable, then we need to terminate it. And the word already says the word itself, terminate. So it means it needs to be in the end. So we're going to put 50 ohms in the T connector. So we are actually terminating it exactly here. And that is where we have our high impedance to make it low impedance. So just remember it needs to be always in the end, no? Because sometimes I see that people put it there. That is nice, but you really need to put it in the end. That is here. So now we're going to do proper measurement. So, okay, we connect it with the terminator. We switch it on. We'll start. I think you can see the display. Okay, we put in auto mode. And here we have the wave. And we are now on 1 megahertz. And you see the wave kind of looks stable. I'm here at amplitude 5 volt. It says here it is 2.58. Peak, well, it is divided by the 50 ohms there, so that is okay. We can do zoom in a little bit. Well, that looks fine. And yeah, you see it's a little bit shaky, but it is okay. So I like to go to 10 megahertz to see what that does. So I go to 10, 3, 4 is 10. We need to, well, we can do ourselves. Oh, that works nice. The trigger is still there. But now you see, and I can zoom in a little bit, it already starts to be jumpy. Yeah, so you can see that it already starts to be a little bit jumpy. Maybe I can zoom in a little bit more. This is at 10 megahertz. And if you think, oh, that is maybe the signal generator, let me put it on the signal scope to show you. Same cable. Of course, I also need to terminate it, so I just take the whole terminator and put it here. And here we have it. Super steady, not shaking at all. So I think we can say it's not a generator. So already at 10 megahertz it starts to be a little bit shaky. But that's okay. Let's see if we can do more. Okay, let's go to 30 megahertz. 20, 30. As you can see, the wave also, it's more or less stable. That is okay. 30 megahertz. We can zoom in a bit. Yeah, now it is really a lot more jumpy. So it already has a little bit of a problem getting the waves. Now it is with this sampling. No, that doesn't help. I'm already at the limit of zooming in, and that is at 30 megahertz. So if I go a lot higher, I cannot even zoom in more on the wave. Okay, interesting. So if I go to 50, or go to 60, it's the maximum for this generator. Now it's really jumpy. And I can also not zoom in more. So I'm already at the limit of my, if I want one full wave, because I'm already at the limit of my time, then I really, a full wave should be like this. So that is at 20 megahertz. No, I cannot zoom in more. If I do automotive, probably end up with exactly the same. Yes. Well, I can do the rest with the Marconi because I cannot go much higher with this field tech. Okay, this is 50 megahertz with the Marconi. It has a little bit less output because my maximum is here 223 millivolts on this high frequency. But you see, it's still jumping a little bit. So, but now I can try to go up to 100. First do 90 megahertz. And you see, now he's completely lost also his zero. Now we need to go up. That is a bit silly. And I cannot zoom in because we are at the maximum of the time. Right. You're not seeing what I do. I'm pushing here the seconds or the milliseconds to zoom in or zoom out. But and if I do a different voltage, it just completely loses his center. Look, it just goes up. So then you need to go down, then you go to another scale, then you need to go up, another scale, another scale. We need to go up. Okay, that's a bit silly. So if we are now 90 megahertz, if you really want to see something, yes, you cannot. Because you see, yeah, there is not enough resolution right now. Let's just go to 100 also, then have it done. Okay. Let's see if we can do something on auto. Even the auto setting. Okay, that is not helpful, I think. Let's go down. I have no clue what it is doing right now. It's dancing all over the place. Now 110. Yeah, okay. Let's try 25 megahertz. I think that is more realistic. But even then, it's not stable. 10 megahertz. Hmm. One. Yeah, it is better. It is still moving a lot, but at least at 1 megahertz, it is kind of stable. Yeah, this looks okay. Just to see the difference on how it should look on our oscilloscope, I'm putting now 50 megahertz, and it says it's a peak of 600 millivolts, and now I'm going to 90 megahertz, and it's still 600 something millivolts, and you see the wave is still not jumping. It's not doing anything. If we want to zoom in a bit, we can do that. If I go to 110, nothing is jumping. It's super stable. But of course, that's exactly the difference. Now you need to realize if you buy an oscilloscope around 400 or about $60. So I'm now doing 500 hertz, and it actually looks quite good. You can really zoom in, and you can walk your way, and it's kind of stable. So really, it is very nice for low frequencies. So that's it. Outcome a little bit unexpected because I already said I didn't want to burn it, and because it's just a cheap device. But I was a little bit disappointed because yeah, everything above 1 megahertz almost is becoming unstable. It picks up a lot of distortion on the sine wave. And you actually would think then that your wave is not good that you're measuring. But if I look on my cyclant, it is just super clean signal. So yeah, maybe for automotive this is nice. For audio it is nice. But really the 110 is not true. So I hope it helped. I would have hoped to have a better verdict on this. And, thank you for watching, and I hope to see you next time.